Hi, this is Mr. Gillum, and today we're going to learn how to add and subtract vectors and how to apply that information. So, when we're adding vectors, the name of the outcome is called the resultant. So when I'm adding vectors, the name of the outcome is the resultant. All right, there's two ways to graphically add the vectors together. Okay, one way is called the parallelogram method. And to do the parallelogram method, what we do is we start with just two vectors, and we align their initial points up exactly in the same spot. What we do after we have these two vectors exactly lined up with their initial point in the same spot is we make a parallelogram. And the diagonal of the parallelogram is the resultant, or the sum, of the two vectors. Okay, this is probably the least popular way to do this, but it is important to be aware of it. So if I had to find the sum of the vectors using the parallelogram method, what I would do is and this is just going to be a sketch, I'd line up the vectors with their initial points in the same spot. There's vector A and vector B. From there, I would make a parallelogram to the best of my ability. I'll try to make it legitimate so you can see here. Parallelogram, and the sum is actually the vector, the diagonal of the parallelogram. So this would be vector A plus vector B. Okay, so that I can move it out here now if I wanted to. This would be vector A plus vector B. Okay, so that's one way to do it. Okay, using the parallelogram method. Another way to do it is called the triangle method, and I think this is a lot more popular than the parallelogram method. But what I do with the triangle method is I take my first vector and I draw it, x, and where the terminal point of x is, I start drawing vector y. Now, wherever the end of the magnitude of vector y is, the initial point of x connected to the terminal point of y represents the sum of the two vectors. So I can show you again here, if it was the parallelogram method, I would be putting the initial points in the same spot, like so, and making this parallelogram. As you can see, it's the same exact vector. Oops, I should draw it the other way around. It's the same exact vector that we found with the parallelogram method, but we use a triangle method instead. So the triangle method again just says I'm going to draw my vector. At the first vector's terminal point, I draw the second vector. Wherever we end up, I start with my initial point, connect it to my final terminal point, and that vector represents the sum, the resultant of the sum of the vectors. So again, this is just a sketch, so I'll do my best to find the sum of the two vectors using the triangle method. So I'm going to take vector A. I'm going to try to copy it nearly as perfectly as I can. That looks like about angle A, or vector A. I'm going to start B, and I can't change its direction. It's going to start B right there. That represents vector B. Now I'm not measuring or anything, so this is just as close as I can do freehand. The triangle method says if I have the initial point of A and the terminal point of A, and I start the initial point of B on the terminal point of A and draw that vector, wherever that ends up at represents the sum of the two vectors. So the pink vector there, it's too long. The pink vector, something like that, represents the sum of vector A and vector B, or the resultant of vector A and B. Okay, so we have the parallelogram method and the triangle method. When I ask you to subtract the vector, just like regular addition, if I have 3 minus 2, it is the equivalent of 3 plus negative 2. Okay, so when I'm adding vectors, or subtracting vectors, I should say, it's just like adding the opposite. So just to review, if this is vector A with the initial point here and the terminal point here, its opposite would have its initial point at the former terminal point and go the opposite direction. Same way with B, its opposite would start here and go that way. Okay, just goes the opposite direction. So same length. So for instance, if I'm finding the difference of the two vectors, I would start with A and I would draw it. If I'm doing A minus B, a vector A minus vector B. I would start with A and using the triangle, I'm using the parallelogram method. Okay, I'm also going to put this point right here, and instead of drawing it this way, like B, I'm going to draw it in the opposite direction, like that. And so the parallelogram method says, okay, we need a parallelogram. This diagonal here is the difference of those two. I'll highlight it for you. That would represent the difference of the vectors right there. Okay. Let's take a look again, and if I wanted to do it with the triangular method, same exact thing, vector A minus vector B. I would start with A, and I would draw A. It's not a very good angle. And instead of, it's a little too long. Instead of starting B and going this direction, I'm going the opposite way of B. So I'm going to start right there, and I'm going to go this way instead. And so the resultant vector will be this guy right here, which should look pretty close to what we had here. My sketches are pretty accurate there. Okay, so either way you prefer it, parallelogram method or vector method is fine. When they give you specific coordinates in composite, or let's see here, when they give you these vectors in component form, you can just literally just add the numbers x1 and y, or x1 and x2 together. The sum of the vectors would be right there, and y1 and y2, their sum. That's the new component form of the new vector. So if they give it to you in component form, it's very easy. If they don't give you an actual length, or you don't know how far, what the magnitude or direction of the vector actually is, it'll be more of a sketch for today. Okay. Now we do have one word problem here that we're going to solve using vectors, and it's kind of a long word problem. It says that cheerleaders are using an air launcher to project t-shirts into the stands. So here's a cheerleader, and they're shooting this thing into the stands. Here's the stands of all the people. All right, they're shooting these t-shirts out into the stands. The wind is blowing in the same direction that the t-shirts are launched. So the wind's blowing like this. Okay. If a shirt leaves the launcher at 40 feet per second at an angle of 45 degrees, and the wind is blowing at 7 feet per second parallel to the horizontal, what is the resultant velocity and direction of the t-shirt? Okay. So what we did, when it says resultant, that tells you you're dealing with vectors. So we see that on like a test or a park or anything like that, it says resultant. Think in terms of vectors. What I did is I pulled these two diagrams here for the two information that I'm talking about. The launcher at 40 feet per second at an angle of 45 degrees. So I'm going to start with that. And I have this 45, 45, 90 triangle here. And so what I'm going to do is I'm going to solve this triangle. Okay, I'm going to solve it. I'm going to say, okay, well, if that's 40, then this is 40 over root 2. Or better yet, if I rationalize 40 over root 2, equals 20 root 2. So I'm going to say that each of these sides, x and y, must be 20 root 2. Okay, and the wind diagram comes from, it says that it's blowing at 7 feet per second parallel to the horizontal, meaning that our vector is just going straight from left to right. Okay, what I'm going to do here is I'm going to add these vectors together. And I'm going to choose to do this in composite form, meaning the horizontal distance compared to the vertical distance in this case will be 20 root 2, 20 root 2 of this first vector representing the t-shirt. The composite vector here will be represented by 7, 0. Okay. 7, 0. Means I'm moving left and right 7, I'm moving up and down 0. It's parallel with the horizontal. So I have these two composite forms, and That's why I was just talking about if they're in composite form, things are good because I can just add the x values and add the y values, and that's the sum of the vectors. And so that's exactly what I'm going to do. I'm going to say when I add this guy plus this guy, I'm going to say that makes 20 root 2 plus 7, comma, 20 root 2. That is the resultant vector. And so what I'm actually going to do is I'm going to get an actual decimal value here. So it actually makes sense. 20 times the square root of 2 plus 7 is 35.28 approximately. And 20 root 2 itself is 28.28. Okay, so that is the resultant vector. That's awesome, but I haven't actually answered the question yet. So I'm just going to sketch this vector here. This represents this component form vector, the sum of the two vectors. And that tells me that it has a horizontal change of 35.28 and a vertical change of 28.28. What it asks us to do is find the resultant velocity and direction. Okay. Now our velocity is represented by the magnitude of our new vector. So what I need to know is I need to know what this is. I'm going to call it v because we're talking about velocity. The direction is represented by this angle, what we've been learning about. So I need to use trigonometry to find both my velocity and my direction. So for my velocity, instead of using trigonometry, I'm just going to go ahead and use the Pythagorean theorem. I'm going to say 35.28 squared plus 28.28 squared should equal my velocity squared. And because I know you know the Pythagorean theorem, I'm going to go ahead and just type that in real quick and find the result all in my calculator at the same time. It looks like it's 2044.44, and I will find the square root of that. Looks like it's about 45.22, and again, technically, if we were solving a quadratic equation, there'd be the plus and the minus. In this case, we're talking about a distance. So looks like my magnitude is 45.22, and that will be represented as a velocity. So 45.22 feet per second. Okay, that is the magnitude. I also need to find the direction. So I need to find this angle. It looks like I have an opposite and an adjacent. So I'm going to find the tangent of the unknown angle equals 28.28 divided by 35.28. So I'm going to go ahead and do that in my calculator as well. 28.28 divided by 35.28 equals 0.801. I guess I can write that down just so there's no confusion. 0.8016 we'll say. And then I take the inverse tangent. I find the inverse tangent of both sides of the equation, and it tells me 38. Take the inverse tangent of both sides. And so I know that the direction is represented by 38.7 degrees. Okay? And so there you have it. We have solved the word problem, and we've actually answered it 45.22 feet per second, as well as a direction of 38.7. Like I said, the keyword there is resultant. When you see a word like that, you're thinking in terms of vectors. Okay, so that's it for today.